Weather on other planets is one of the most mysterious and fascinating aspects of our solar system. Each planet has its own unique climate and seasons that are influenced by various factors, such as its distance from the sun, its rotation, its tilt, its atmosphere, and its magnetic field. Some planets have weather that is similar to Earth's, such as Mars, which has dust storms, clouds, and ice caps. Other planets have weather that is very different from Earth's, such as Venus, which has a thick atmosphere of carbon dioxide and sulfuric acid that creates a greenhouse effect and a surface temperature of 460 degrees Celsius. But among all the planets in our solar system, there is one that stands out for its extreme and unpredictable weather. It is Neptune, the eighth and most distant planet from the Sun, and one of the coldest. Neptune is so far away from the Sun that it takes 165 years to complete one orbit around it. That means that we have only seen one season on Neptune since it was discovered in 1846. But even in this short time span, we have witnessed some amazing changes in its atmosphere and weather. It turns out that the clouds on Neptune, which are mostly made of methane gas, have almost disappeared since 2019, and that this phenomenon is linked to the solar cycle, which is the 11-year cycle of the Sun's activity. This is a remarkable finding that challenges our understanding of Neptune's atmosphere and its connection to the Sun. In this video, we will explore this discovery in more detail and explain why it is so important and what it means for our knowledge of the solar system. But before we start, if you enjoy our videos and want to support us, please consider joining our channel as a member. Let's get started. Neptune is a gas giant planet, meaning that it has no solid surface and is mostly made of hydrogen, helium, and methane. It is also an ice giant, meaning that it has a thick layer of water, ammonia, and methane ice under its atmosphere. This planet is about 4 times wider than Earth and 17 times more massive. It orbits the Sun at a distance of about 4.5 billion kilometers, which is 30 times farther than Earth. Because of this huge distance, Neptune receives very little sunlight and heat from the Sun. Its average surface temperature is about minus 200 degrees Celsius, making it one of the coldest places in the solar system. Neptune's atmosphere is very dynamic and stormy. It has powerful winds that can reach speeds of up to 2,100 kilometers per hour, which is faster than any other planet. It also has giant storms that can last for years or decades. One of the most famous storms on Neptune was the Great Dark Spot, which was first observed by NASA's Voyager 2 spacecraft in 1989. It was a huge oval-shaped storm that was about the size of Earth and had winds of up to 2,400 kilometers per hour. However, when the Hubble Space Telescope looked at Neptune in 1994, the Great Dark Spot had vanished. Instead, another storm had appeared in the northern hemisphere of Neptune. This showed that Neptune's weather is very variable and unpredictable. One of the ways to study Neptune's weather is by looking at its clouds. Clouds are formed when gas molecules in the atmosphere cool down and condense into tiny droplets or crystals. On Earth, clouds are mostly made of water vapor, but on Neptune, clouds are mostly made of methane gas. Methane absorbs red light from the sun and reflects blue light, which gives Neptune its beautiful blue color. The clouds on Neptune are usually white or pale blue, but sometimes they can appear dark or bright depending on their altitude and thickness. The clouds on Neptune are not evenly distributed across the planet. They tend to form more frequently at certain latitudes and seasons. For example, during the southern summer on Neptune, which lasted from 1980 to 2020, there were more clouds in the southern hemisphere than in the northern hemisphere. This was because the southern hemisphere received more sunlight and heat from the sun than the northern hemisphere, creating more convection and turbulence in the atmosphere. The southern summer also coincided with a period of high solar activity, which means that the sun had more sunspots and eruptions than usual. Sunspots are dark areas on the surface of the sun that have strong magnetic fields. They appear and disappear in cycles of about 11 years, which are called solar cycles. During a solar cycle, the number and size of sunspots change over time. The peak of a solar cycle is called solar maximum, when there are many sunspots and eruptions on the sun. The low point of a solar cycle is called solar minimum, when there are few sunspots and eruptions on the sun. The solar cycle affects not only the sun, but also the entire solar system. In fact, the sun emits different types of radiation and particles that interact with the planets and their atmospheres. For example, ultraviolet radiation from the sun can heat up and ionize gas molecules in the upper layers of a planet's atmosphere, creating a layer called the ionosphere. The solar wind, which is a stream of charged particles from the sun, can also influence a planet's magnetic field and cause auroras or polar lights. Neptune has both an ionosphere and a magnetic field that are affected by the solar cycle. However, until recently, astronomers did not know how much impact the solar cycle had on Neptune's weather and clouds. They assumed that because Neptune was so far away from the sun, its weather was mostly driven by its internal heat rather than by external factors. But in 2019, something unexpected happened. Astronomers using two powerful telescopes, the Keck Observatory in Hawaii and the Hubble Space Telescope in orbit around Earth, noticed that Neptune's clouds had dramatically changed over the past 3 decades. They compared images of Neptune taken from 1989 to 2019 and found that the cloud cover on Neptune had decreased by about 40%. This was especially noticeable in the southern hemisphere, where the clouds had almost disappeared. The northern hemisphere, on the other hand, had more clouds than before. Okay, so now, what could explain this sudden change in Neptune's clouds? Well, astronomers realized that it was related to the solar cycle. They found that Neptune's cloud cover was correlated with the solar activity, meaning that when the sun was more active, Neptune had more clouds, and when the sun was less active, Neptune had fewer clouds. This was surprising because it suggested that the solar cycle had a stronger influence on Neptune's weather than previously thought. But how does the solar cycle affect Neptune's clouds? Astronomers proposed 2 possible mechanisms. One is that the solar wind can modulate the electric currents in Neptune's ionosphere, which can in turn affect the winds in circulation in the lower atmosphere. The other is that the ultraviolet radiation from the sun can change the chemical composition and temperature of Neptune's atmosphere, which can alter the formation and distribution of clouds. Both mechanisms are still hypothetical and need more research to be confirmed. The discovery of the link between the solar cycle and Neptune's clouds is important for several reasons. First, it shows that Neptune's weather is more complex and sensitive than we thought. It also reveals that Neptune's weather is not only influenced by its internal heat, but also by external factors such as the sun. Second, it challenges our understanding of how planets interact with their stars and how their atmospheres evolve over time. It also raises new questions about how other planets in our solar system and beyond are affected by their stars. Third, it demonstrates the power and value of long-term observations of distant worlds. It also highlights the need for more advanced instruments and missions to explore Neptune and its mysteries. Neptune is a fascinating planet that still has many secrets to reveal. The discovery of its cloud disappearance is just one example of how much we can learn from studying its weather and climate. By observing and understanding Neptune's weather, we can also learn more about our own planet and its place in the solar system. We can also appreciate the beauty and diversity of nature and its wonders. Thank you for watching this video. We hope you enjoyed it and learned something new and exciting about Neptune and its clouds. If you liked this video, please give it a thumbs up and subscribe to our channel for more videos like this. And don't forget to share your thoughts and questions in the comment section below. We would love to hear from you. Until next time, stay curious and keep exploring.